sun were made of bananas, it wouldn't make any difference, or at least it wouldn't make much difference. What you need to know is that the sun is hot for an incredibly simple reason, because it contains a lot of matter, a lot of mass. And all that mass is crushing down on the core. Gravity is squeezing it. And as anyone who's ever squeezed the air in a bicycle pump knows, it gets hot. And at the centre of the sun, the temperature is about 15 million degrees. And at that kind of temperature, matter dissolves into a kind of amorphous, anonymous state known as a plasma. It doesn't matter what that matter is, it always ends up in that state. So the sun is something like a billion tons of mostly hydrogen gas. But if you were to get a billion tons of microwave ovens and put them in one place, or a billion tons of bananas, you'd get something equally as hot as the sun. But what I've told you is why the sun is hot at this instant. I haven't told you why it stays hot, because clearly the sun is pumping heat into space. Now what we know is the sun doesn't seem to get noticeably cooler. So what that tells us is that something is replacing the heat exactly as fast as it's being pumped into space. Now in the Victorian era, in an age which was powered by coal and steam, it was obvious to think that the sun was a giant lump of coal. It would be about 1 million kilometres across. It would be the mother of all lumps of coal. But it was easy to work out how long a lump of coal that size would take to burn out. I mean, all you had to do was take a lump of coal in a grate and really just time how long it took to cool down and scale it up to the size of the sun. That calculation was done, and it was found that the sun could only burn for about 5,000 years. Now that wasn't even enough for Archbishop Usher. He was an Irish bishop who calculated from the Bible that the earth, and by implication the sun, were born on the 23rd of September 4004 BC at 9 a.m. But it wasn't enough either for the geologists. They'd seen mountains like the mountains in Madeira, which were about 10,000 feet high, and you find fossil shells on the summits. So the inference is that those mountains must have been beneath the ocean at some time and risen up. But no one sees a mountain rise up in a human lifetime. So it was obvious it would take tens of millions of years. Then there was Darwin with his theory of evolution, which said that all organisms on Earth had evolved from a common ancestor by a process of natural selection. Well, no one sees organisms change in a human lifetime. So again, you needed hundreds of millions, if not billions of years for biology to create the diversity we see today. And now we know from meteorites, which are the builder's rubble left over from the formation of the solar system, that the solar system is about 4.5 billion years old. So in a way, it's roughly 1 million times older than it can be if the sun were made of coal. Or to put it another way, whatever is powering the sun is an energy source 1 million times more potent than coal. And in the 20th century, that energy source became apparent. It was nuclear power. And what we think the sun is doing, or what we know the sun is doing, is fusing the nuclei, the cores of the atoms of hydrogen, the lightest element, together to form helium. And sunlight is the byproduct of that process. And I just want to finish by telling you how amazingly inefficient that process is. If you were to take your stomach and a portion of the core of the sun, the same size and shape as your stomach generates heat at a greater rate. So you might think to yourself, how does the sun stay hot? Well, the sun stays hot because there's an awful lot of it. There is not just one chunk the size and shape of your stomach. There are countless quadrillion all stacked together, and that's why the sun is hot. But it's because of that incredibly inefficient nuclear reaction that the sun uses that the sun will take something like 10 billion years to burn its fuel, and there's been time for the evolution of complex life like you and me.